Today's lesson is going to give us our last method of solving for quadratics, and this is using the quadratic formula. So this first page that I've attached here just walks you through what the actual quadratic formula is. If you're interested in where it comes from or how they came up with it, I would encourage you to go to lesson 912 and read through the math notes box, because they do take you through the process of deriving the quadratic formula. But for our purposes right now, we are just going to put it into practice. So it says one way to calculate the roots of a parabola is by using the quadratic formula. The formula uses values of a, b, and c from a quadratic equation written in standard form. And then it puts it into this big formula here. When reading this, you would say that x equals the opposite of b. So notice, I'm going to put some notes in here so that we know how to say this. X equals the negative sign here. I refer to that as the opposite of b. And I do that because sometimes b is positive and sometimes b is negative. And so we need to understand that we want the opposite of whatever b is. Plus or minus, again, here's this symbol that we saw on Monday. Plus or minus the square root of b squared minus 4ac, and then we say that that is all over 2a, all divided by 2a. So that entire quantity up top, it's as if there are parentheses around it, and you have to figure that out before you go and divide by 2a. This makes it a little complicated in our calculators, but we're going to break it down to see how that works. So again, when the quadratic equation is in standard form, it looks like this: ax squared plus bx plus c. So it is the coefficient of x squared, that is a. It is the coefficient of x, or the linear term, that is b, and then our constant term is c. Make sure you understand that we are calculating two possible answers by using that plus or minus symbol. Right here, it shows that you have one, just like we did with completing the square on Monday. We have one that would be the opposite of b plus that square root divided by 2a, and then the opposite of b minus that square root divided by 2a. I'm going to go ahead and just side note here that b squared minus 4ac, this is what we call the discriminant, instead of constantly having to call it b squared minus 4ac, and that'll come into play a little bit later, and I'll talk about it again on Monday. But this is called the discriminant. So that you know, I'm pretty sure I spelled that right, discriminant, yes. So that you know what I'm referring to when I say that from time to time. All right, so we're just simply, all we're doing today is putting into practice the quadratic formula. So at the top of this page, I'm just going to write it again. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to put it into practice here. I've got 3 examples, and then that's it. It'll be a shorter video for today. So in this situation for a, the equation is 3x squared plus 7x plus 2 equals 0, already in standard form. So all I need to do to begin is to identify my value of a. In this case, it is 3. B is 7. C is 2. Once I have those numbers in place, I can put them into the formula. I highly encourage this first step. In fact, I would say I absolutely need to see it every time you do this. I want to know that you guys understand where to put the pieces and parts. So the very first step would say the opposite of b, which is 7, plus or minus the square root of. I'm going to take b, which is 7, and square it. Notice I put that in parentheses. Minus 4 times 3 times 2. 4 times a times c, all over 2 times 3. And now at this point, I know a bunch of you want to just pick up your calculators and type that all in. And if you were to type it in exactly as it looks and so careful, then maybe you'd be okay. But there's actually some value in going through and simplifying it by hand some. I just, most of the time you can do this by hand without having to pick up your calculator. So I'm going to walk you through that. So it's the opposite of 7 plus or minus the square root of, excuse me, 7 squared is 49, minus 3 times 2 is 6 times 4 is 24, all over 6. So I've got negative 7 plus or minus. Now, honestly, I pick up my calculator so many times just to do subtraction. It's kind of sad. Plus or minus the square root of 25, all over 6. So I have negative 7 plus or minus 5, because the square root of 25, that's a perfect square. That's kind of nice. All over 6. And at this point, I'm going to break it into my two answers here. So I'm going to have negative 7 plus 5 over 6, which is negative 2 over 6, or negative 1/3. And then I'm going to have negative 7 minus 5 over 6. And negative 7 minus 5 is negative 12, divided by 6 is a negative 2. So I have my two solutions using the quadratic formula. And honestly, I probably could have beat the majority of you solving that by hand and writing those steps out, as opposed to punching it into my calculator and trying to come up with the right answer. So again, your work is going to be important here. We're going to start this process again for B. We're going to start the exact same way. The very first thing I always do is write down my values for A, B, and C, which happen to be 2, negative 9, and negative 35. So this is going to put into play a few extra problems here, things that might get in our way a little bit. I'm just going to put a division here so that we have some room to work. I'm going to write out my formula. So x equals, now I need the opposite of B. The opposite of B. The opposite of negative 9 is 9. Plus or minus the square root of, now I go back to what B is. B is negative 9, so I go negative 9 in parentheses squared minus 4 times 2 times negative 35 all over 2 times 2. And I can start my simplifying now. So 9 plus or minus the square root of, negative 9 squared is 81. Positive 81, not negative 81, positive 81. Then it's going to be, notice I've got a minus 4 here, but I've got a negative 35 in the parentheses. Those two negative signs are going to cancel each other out. So it's going to become plus 2 times 35 is 70 times 4 would be 280. This is all over 4. I'm going to continue with my simplifying. 9 plus or minus the square root of 361. I happen to know that's a perfect square. I don't know if you guys do. So that's 9 plus or minus, I think that's, let me see, 361. Square root of it's 19. 19 over 4, and now I can break it into my two solutions. 9 plus 19 is 28 over 4, so 7 is one of my solutions. And then I've got 9 minus 19 is negative 10 over 4, and that is negative 2.5 is my other solution. So far these have worked out fairly well, nice, pretty neat numbers. There is a good chance, not even a good chance, I can tell you that those two would have been factorable. But sometimes it's nice to just practice the quadratic formula with ones that are factorable so that they come out a little bit neater. I'm going to go ahead and I'm going to look at this last problem. And then you'll have had 3 examples of me walking through. I would suggest that you be following along, maybe stop and start these examples and try and make sure that you're getting the same answers. And then if you need some troubleshooting, you can email either Mrs. Huckel or I, depending on who your teacher is. So we've got A, B, and C. In this situation, notice there is no coefficient of x squared. That means A is simply 1, B is -5, C is 9. So I start out plugging everything into the formula. So x equals the opposite of B. Again, B is negative, so that'll be positive. Plus or minus the square root of -5 squared. Any B squared is always going to be a positive number. There is absolutely no way. If you got a negative value for B squared, then you did not square it correctly. I just want to point that out. That doesn't mean you won't necessarily get a negative under the parentheses, just that B squared should never come out negative. So 4 times 1 times 9 all over 2 times 1. So it's 5 plus or minus the square root of 25 minus 36. Now we're going to run into a problem because this becomes 5 plus or minus the square root of -9 over 2. This can't happen. This can't be done. You cannot take or get a real number answer to a negative square root. This simply means there are no x-intercepts. So when we end up with that negative under the radical sign, it means we have no x-intercepts. We can go and double check it. That doesn't mean that the function doesn't exist. It just means, let me find my Desmos here. It just means that the function doesn't cross the y-axis. And that will happen from time to time. Minus 5x plus 6. Nope, plus, it wasn't plus 9. Sorry, plus 9. There you go. So what you're seeing is that this parabola exists, and there's a vertex for sure, and there's a y-intercept, but there are no solutions, there are no roots, there are no zeros, because this parabola doesn't cross the x-axis. And we are going to talk about that again on Monday and what that actually means. But for now, this is it. Just practicing that quadratic formula and going through those steps. Here is your homework. Problems 17 through 21. They're not due till Monday, so you have plenty